Everyone. We're going to calculate the pH of a dilute strong acid in this example, and here it is. It certainly is dilute at 10 to the negative 8th molar, and it certainly is a strong acid. So it's tempting to begin the problem by saying that as strong acid, HCl dissociates 100% into H plus and chloride. And it's tempting to say that if HCl is 1.0 times 10 to the negative 8th formol, then H plus must be 1.0 times 10 to the negative 8th molar, and chloride must be 1.0 times 10 to the negative 8th molar. And then you could say, well, the pH is the negative log of the hydrogen ion concentration, which is 1.0 times 10 to the negative 8th molar, and you get 8.00, right? 2 sig figs in N means 2 digits in the mantissa of A. And then you start scratching your head because you got a basic pH for a strong acid. That can't be. We must have forgotten something, and what we have forgotten is another source of H+. We failed to consider H+ from the dissociation of water. So you know what that means. That means we have to use the systematic treatment of equilibrium if there's more than one reaction at equilibrium. Let's try it. Step 1. Write down all relevant chemical reactions. So HCl dissociates 100% into H plus and chloride, and then the reaction that we forgot, which is why we got into trouble, is the dissociation of water. Step 2, write a charge balance. Positives on one side, I think those are all of my positives, negatives on the other. Step 3, write a mass balance. And we can't say H is equal to OH because there are two sources of H+, but at the very least, maybe we have that trivial mass balance where the chloride concentration is 1.0 times 10 to the negative 8th molar. Step 4, write down all of your K expressions. Well, the only one we have is Kw, which is equal to H times OH. Step 5 is where we stop and reflect, and I think we have enough equations to solve this problem. So what I'm thinking we might want to do is plug in this chloride ion concentration here, and then what can we plug in for OH here? Well, maybe we rearrange this Kw expression. That would be Kw over H plus, and this is what we can plug in for OH. So our new charge balance then would be H plus is equal to, again, I'm not going to write OH, I'm going to write Kw over H plus. And then chloride is known, but I'm going to substitute in that concentration a little bit later. For now, I want to get rid of this fraction here and multiply both sides by H plus. So H plus squared is equal to Kw plus the concentration of chloride, which again is known, times H plus. And then I'm going to get everything on one side of the equation. That's H plus squared minus the concentration of chloride, which was 1.0 times 10 to the negative 8th molar times H plus, minus Kw, which is 1.0 times 10 to the negative 14th equals 0. And now I've got this quadratic equation in a form that I like. Ax squared plus bx plus c equals 0. And now I'm ready to use the quadratic. If I remember the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So negative b would be 1.0 times 10 to the negative 8th plus or minus b squared. That's negative 1.0 times 10 to the negative 8th squared minus 4. A is just 1. C would be negative 1.0 times 10 to the negative 14th, all divided by 2, because A is just 1. And then that gives 1.0 times 10 to the negative 8th plus or minus. And then I did all the arithmetic here and got 2.0 times 10 to the negative 7th, all divided by 2. And the only sensible solution would be to add this number here, right? If we were to subtract, we would get an absurd value because the H plus concentration would be negative. So we have to add, and doing so gave me 1.0 with an insignificant 5 times 10 to the negative 7th molar H plus. And now when you take the pH of that, when you take the negative log of this number, you get 6.98, which is more reasonable for a dilute strong acid like HCl. It's a little bit acidic, but it's so dilute that it's close to neutral. So Harris recommends using the systematic treatment of equilibrium when the H plus or even the OH concentration for a dilute strong base is less than 10 to the negative 6 molar. So I hope you enjoyed the video, and thanks for listening.